Hey guys, Parth and I will be talking about microexpressions and how we use XAI to analyze them. So, what are microexpressions? These are facial expressions that occur within a fraction of a second. Uh, in simple words, they are too fast to be captured by a naked human eye. So, these are better off, captured if you have a high-speed camera or something. But how are they of importance to us? Microexpressions are actually a result of suppressed emotions. They cannot be prevented from occurring, unlike macro expressions. So now Parth will actually explain to you all how we designed this architecture and what was our mini project. That is how we detected micro expression and later on how we analyzed them.
Yeah, thank you, Rahil. So basically, we divided our deep learning model architecture into three phases. The first block, as you can see, was the pre-processing block. After that, uh, we used some pre-existing models such as VDC16, Resonance T, and a few more. And then we passed the images to the fully some FC layers. Uh, so in the pre-processing block, as you can see, we used a graph cut algorithm to maintain the to cut down the various backgrounds of the image and bring a clear black background for all the images. Yeah, and so these were some findings of our deep learning model. And from here you can see the mobile net model, which we used as a intermediate model, gave out the best results. So we used this model as a part of our XAI implementation for the. Yeah, so basically, what is XAI? So as you can see, deep learning models are mostly black boxes. You cannot see what's happening in between them and why the model or the architecture is predicting that particular results. So XAI basically helps us to analyze and detect why the deep learning model predicted that specific outcome and not the others, and answers various questions uh, like uh, I understand why not. I know when you succeed. I know when you fail, and I know when to trust you. Basically, yeah. So as I mentioned, what is XAI, and to mention the need for XAI in microsystems. Microsystems hold extremely valuable information, but as you can see, they are very difficult to detect and more difficult to basically analyze. So in this case, we are able to detect the microaggression. However, we cannot clearly tell why this microaggression was detected, and in that case, we needed the help of XAI. So this was our XAI model. So we get the data from the data set, then we apply some pre-processing logic uh, as discussed earlier. Then we supply this pre-processed data to both the compiled model, which detects the microprecision, as well as the line or the stack model. So basically, line or the stack models are basically packages, Python packages, which are used to predict the outcome using XAI, and then the compiled model, which basically provides the which microprecision is detected as the output, and side by side, and the live model provides the attention for it.
So now, guys, I will talk about Lime. Lime was actually the library that we use in Python to find out the micro expressions and why a particular micro expression was stored by the deep learning model. So Lime is actually used to solve model interpretability by producing a locally faithful explanation. This is actually a better library than SHAP. I mean, there were a few reasons why, but mainly because it provided local model interpretability. It was less hardware dependent as compared to SHAP because SHAP was very GPU intensive, which is not really good when you use it to train the model over lots of data. So I will give you a brief explanation of how Lime worked. The image on the left, it shows the pixels on the user's face which contributed to his expression of anger. Okay, so all these pixels that you see, these according to the deep learning model are contributing towards anger. And the image on the right, it shows the pixels of the user's face which are not contributing to anger. So the sum of these actually, gives a plus minus value. It is between -1 to +1. So the sum of these, it gives a value of anger. And that's how Lime would work, right? It would show you the pixel which contribute to a particular micro expression and the pixel which negatively contribute to it. This was the evaluation report of MobileNet model. Like MobileNet model was the deep learning model we use, and we use an XAI model over it. So basically, XAI acted as a wrapper model over the previously trained MobileNet model. So this was our output. Okay, so now the thing is, we actually used artificial intelligence to support our previous artificial intelligence model. Okay, so what we thought is, why not get another algorithm? Why not just find out how accurate our AI model actually is and how accurate our XM model actually is? So this is an OpenCV logic that we wrote. This is a novel algorithm. We haven't copied it or anything, So the idea is simple. A video is made out of frames. So let's consider a video made out of 40 frames. And the midpoint of that would be 20, right? So let's consider frame number 1 and frame number 20, frame number 2 and frame number 21, frame 3, frame 22, and so on till the end. So now the idea is simple. We convert the image into a NumPy array, and then we find the difference of the higher array minus the lower array. What this does is it basically shows us a difference in pixel values, okay, over these 20 frames. So now after a lot of testing, we found out that when you set the threshold value of the pixel value to 230, it is the most optimum value. So, for example, you know that, right? Colors are between the range of 0 to 255 for RGB. So we set a threshold as 230. So any color below any pixel value below 230 is automatically assigned to a value of 0, that is black, and any value above 230 is assigned to 255, which is white. So after this, we come to know, which pixels are the most significant contributing to a particular micro expression, or to be more precise, which pixel actually has the maximum change over 20 frames. So this is a flow chart of the same algorithm that I explained right now. And this is the implementation. Okay, so this is the change in the user's face over 20 to 20 frames each. Like for example, the first photo would be frame 21 minus frame 1, second is frame 22 minus frame 2, third is frame 23 minus frame 3, and the last one is frame 24 minus frame 4. So as you can see, the maximum concentration of the white pixels, that is where the change in the change in the micro expression is the most. That was our finding, and what we also found out was the findings of the XAI model that we used, the line model. It actually supported this thing. So basically there was inter supporting between the two, and we could validate that a line model was accurate enough to support our findings. And I mean, OpenCV was really, it wasn't an AI thing or anything. It was pure math. We did addition, subtraction, and we found out the change in pixel values. And yeah, so we computed this for different micro expressions. I think there was anger, happiness, sadness, everything. And after that, we could cross verify, that yeah, it is correct. The XA model was correct. So yeah, this was our major project. And the future scope that we had written back in college was we wanted to develop a web application for the same thing, where the user could in real time upload his image, and our XAI model could analyze the micro expression and serve the response to him. I have also attached some FAQs at the end of the PPT, just in case you want to read or if you have any other questions. It is pretty straightforward. But yeah, that's it. Thank you.